Okay, here we are with example 5 from the exam review, where we need to give a equation for both sine and cosine of the graph shown. There's going to be multiple different answers for this question. Off the bat, I'll just acknowledge that. I'm going to show you one way of getting to a correct answer, but because of the cyclical nature of sinusoidal functions, there are multiple correct answers because there's multiple different phase shifts. You could have picked an answer that has a vertical reflection. However, I'm not going to do any vertical reflections in my answer. So this is just one. These are going to be one of many possible correct answers. But I'll walk you through my method. So there's multiple different things we need to find here, and actually this question is an example of one that does have every kind of transformation. There is a vertical translation, there is a phase shift, there is a horizontal compression, and there is a vertical stretch. So multiple things to consider here. I'm going to start off by drawing the axis of curve down the middle of the graph. That's going to help me find two different values of my transformation. So the axis of curve is what splits the function vertically. That's not a straight line. Which in this case is the line y equals -2. That's really not going to cooperate here as I try to draw a straight line. That's good enough. Okay. I'll make that a little thicker. Okay, so we have the line there, y equals -2. And this has been moved down 2 units. Remember, the axis of curve gives us a c value. Usually this line is at y equals 0, but now it's been down 2 units. So c is going to be -2. And also from the axis of curve, I can then find the amplitude. So if I count up from the axis of curve to a maximum or minimum value, I'll get the amplitude, which in this case is 5. Usually it's 1, but it's been multiplied by 5 in this case, so that's our a value. Two things to find next are the phase shift and the k value, which is affecting the period. So let's do the period first to find the k value. So to find the period, we need to look at how long does it take, what's the distance by ways of x for this function to complete one full cycle, to complete one period. So if I'm looking at this point here at the y-intercept, and I follow the function round to complete one full cycle until there, I can see that that distance is 2 pi over 3. However, that's not our k value, that's our period. We need to remember that the period is 2 pi over k, or equivalent, always equivalent to 2 pi over k. And in this case, the period, or 2 pi over k, is equivalent to 2 pi over 3. And we can see here that the numerators are the same, so the denominators must be the same. So k must be equal to 3. Or you could rearrange it algebraically to isolate for k. You'll get the same thing. K is equal to 3. Last thing we need to figure out is our phase shift, d. So let's take a look. How far over have our sine or our cosine function been moved in order to give the graph shown? And there's multiple different possibilities here, but we do need to look at sine and cos independently. So let's start with the sine function. We know that sine usually starts at 0 and goes up. So I can pick that point there, for example, and I'm going to see that that has been moved over pi over 3 to the right. And for cos, I'm going to look at this point here and see that this has been moved to the left pi over 6. And those are going to give us our d values. So let's put this all together. Let's do sine first. So our a value is 5. Sine, our k value is 3. X, and pi over 3 to the right means negative pi over 3. And our c value is negative 2. And now we can do cos. Remembering cos functions are the same as sine functions, just the phase shift is different. So 5 cos of 3. And then this time it was pi over 6 to the left. So that's plus pi over 6. Subtract 2. And there we go. We are done with two different equations to show the same function, but one is sine and one is cos.